Hello there. Welcome to Anybody Can Code C++ series. So if you're new to this series, you can click on the card that's above to check out our previous videos. Hey there. Welcome to the ABC series of C++ from Facebook. So in the previous video, you had seen a lot of things related to input and output statements, right? So I had told you how to use cout, cin, printf, scanf, and a lot of other things like format specifiers. So in this video of ours related to C++, I'll be teaching you how to use the operators and what are the types of operators and what can be done to use certain sorts of operators, right? So this video is entirely going to be based on five types of operators. So namely, first one would be on arithmetic operations. Second is on assignment operations. Third on relative operations and logical and bitwise operations. And apart from these, there are also certain other special operators which do not, come under any of these categories. So I'll also be discussing slightly on those operators as well. Okay, you can call them as special operators. So let's just start with our operators, shall we? So the first one is arithmetic operators. So arithmetic operators are like plus, minus, and division, multiplication, and you have one more called as modulus operator over here. That is a percentage symbol, what you can see, and you've got incrementation and decrementation operators, right? So I'll tell you what are the usages of these operators. So the most of these you should be familiar with. I'll anyway tell you the other things which you might not be quite familiar with. So here in the compiler, I've just written the template, the basic thing, what is required for me to code. So I have a cout statement over here. So to show you the operations, I'll just declare two variables, so A and B. So here I'll be, assigning the value of A as 10, and I'll be assigning the value of B as 5. Okay, so let's say I want to add these two things. So I'll just be taking A plus B. So I'll just run this particular cout statement. So let's see what we'll be getting. So 10 plus 5, it should be giving me a 15, right? So it's giving me a 15 and it's working fine. And this is my plus symbol or addition operator. Next, subtraction operator. So 10 minus 5 should be giving me a 5. It's giving me a 5. Then I'll take division operator. So 10 divided by 5. Okay, it should be giving me a 2. Correct. So let's see what it gives. It's giving me a 2. Yeah, it works fine. And then multiplication symbol, that is hash trick over there, and 10 into 5, it should be giving me a 50. Yes, superb. So I think these are the four things what you were familiar with, right? So I'll just tell you how modulus operator works. So this is the modulus operator, what I've written over here as a percentage symbol. So modulus operator just gives me out the remainder of whatever calculations I do. Okay, so here it'll be like 10 modulus of 5, or simply in terms as 10 when I divide by 5, what is the remainder I'll be obtaining? Okay, so you already know that 10 is completely divided by 5. Okay, so I'll not be getting any remainder, so that'll be a 0, right? So let's say I change this particular number from 10 to 11. Okay, now if I run this particular program, I will be getting a remainder of 1, right? And that is because 11 divides 5, okay, 1 times, and I'll be getting a remainder 1. Okay, now let's just slightly change the number to 14. Okay, now 14 divided by 5, the remainder what I'll be getting is 4, right? So that is how exactly the modulus operator works, guys. And let's go about with the incrementation and decrementation operators now. So let's say I print a plus plus. Okay, now what we are doing over here is we're just incrementing a to the next position. Okay, from 14, if I increment it to one more. Okay, so let's see what happens if I print a plus plus. Okay, so here it is printing it as 14 itself. Now why? Because we have got something called as pre-increment and post-increment. Now in this particular line, okay, I've used this operation called as a plus plus, which means that in the next line, if I use a again, okay, it will be giving me a incremented value. Okay, now let's see what is the value of a that is being printed by the compiler. Okay, it's giving me 14 and 15. Okay, so you can see over here, the first, a plus plus, it did not increment the value, which means that it was a post increment. Okay, the increment which had occurred in this particular line is being printed in this particular cout statement. Okay, anywhere else in the code, if I use a again, okay, without incrementation, okay, let's just not increment it anymore. Let's just try to print a. Okay, I'll just try to print space over here for your understanding. Okay, so I have got space over here. Okay, now let's just try to compile this particular code. So you can see I have incremented 8 twice. Okay, and it has incremented 8 twice. So this 14 is being printed from this particular cout statement, and it is not being incremented in that particular line itself, which means that next time when a is called, it is being incremented. Okay, next time a is being called over here, so there the incremented value of a is being printed. Okay, that is 15. Next here again it is being incremented, and once it is being incremented, it is not getting print over there itself. Next time when it is called, it is being incremented and getting printed, right? 16. So that is the meaning of post increment, guys. So let me just try to move the plus sign towards the beginning of a. Okay, so I've got plus a. Now this is called as a pre-increment. Now let's see what happens. Okay, I'll just try to run this particular code. So I've got incrementation done 2 times over here. So let's see how it works. Okay, I've got 15, 16, and 16. So you can see here, pre-increment means then and there itself, I'm supposed to increment the value of a. Right, so 14 is being incremented as 15 and is being printed as 15 itself in the first cout statement. And again in the second cout statement, I've got 14 incremented, I'm sorry, 15 incremented to 16, and that is being printed as 16. Okay, and in the third cout statement, there is nothing to be incremented. So the last value of a, that is 16, right? So 14 got overwritten to 15, 15 got overwritten to 16. So 16 is being printed, as simple as that, right? So that is nothing but pre-increment and post-increment, guys. So similarly, you have got pre-decrement and post-decrement. So it just works like the increment operation. So first I'm decrementing the value over here. So 14 is decremented as 13. Okay, that is being printed. Next, 13 is furthermore decremented to 12. That is being printed. And the last value of a, that was 12. So that is being printed in the third cout statement. Okay, now let's see how the decrement operation works for post. Okay, so over here, both are post decrement operations that is being taken care of. So in the first cout statement, it is not supposed to print the decremented value, so it is not printing the decremented value. Second cout statement is supposed to print the previous decremented value, that is 14 had been decremented to 13, so that is being printed. And in the third cout statement, it is printing the decremented value from the second cout statement, right? So here it is printing 12, whereas we have not decremented a over here. So I hope you have understood this particular logic, guys. So basically, you've got plus, minus, division, multiplication, a modulus operator, incrementation operator, and decrementation operator. Now let's go for the other one. And the next type of operator what we have is assignment operator. Now it's quite simpler, guys. You might have already seen what an assignment operation is. So this is nothing but assignment operation. And so I've given a is equal to 14, which means that I'm just storing 14 inside a. That is called as assigning. Okay, I'm assigning 5 to b. Okay, that is called as assigning. Now there are a lot of other things which can be done when it comes to assignment operators. So let's say I want to print a plus b. Okay, I'll take one more variable called as c, one more integer variable called as c, and I want to store the value of a plus b in c. Okay, so c is equal to a plus b. Okay, so if I try to print c over here, it is supposed to give me the value 15. So let's check what exactly it gives me. Okay, what happened? Yeah, semicolon was missing. So you can see, 14 plus 5, okay, it is giving me the value of 19 over here. So that is the value that is being stored inside C. Okay, I've assigned 19 inside C. I'm trying to print C. So it is giving me a value 19. Right, so this can also be simplified, in certain processes. Now let's say I want to store this particular value in A itself. Okay, and I want to print A. Okay, this can also be done, guys. Basically, it'll just override the values. So 14 plus 5 is 19. 19 is overwritten, okay, and assigned to A. Okay, now the value of A has changed from 14 to 19, and it is being printed. Okay, now let's say I want to, without using much of these symbols, I want to write this particular line. Okay, this A is equal to A plus B. So how I can write this particular line is, you can see over here, plus equal to, right? So I'll just write this particular statement. So A plus equal to B. Okay, now let's run this particular code and check what happens. Okay, I'm still getting 19, which means that even if I write A is equal to A plus B, okay, let me just write this down in comments. Okay, A is equal to A plus B. Okay, or even if I write A plus equal to B, it means the same thing. Okay, this is one more assignment operation what we can consider. Okay, now let's check for multiplication how it works. So A minus equal to B means A is equal to A minus B. So let's just run this particular code and check what happens. So I've got 9, right? So 14 minus 5 is equal to 9. So that is exactly how it will work, guys. So no matter what particular operation you'll put over here, so let's say A hash trick equal to B, which means that A is equal to A into B, right? So if I run this particular code, 14 into 5, so that will be giving me the value as 70, right? So that is exactly how it works. Okay, so this is one more operation we have got. It will also work for a modulus operator. Okay, A modulo equal to B means A equal to A modulus of B. So I hope you have understood the assignment operators, guys. Now let's go for the next part. So the next part is relational operators. So as the name says, you'll be comparing things over here, right? So you've got basically equal to, not equal to, greater than, less than, or greater than, greater than, equal to, lesser than, equal to. Right. So how exactly does it work? So let me just keep the same values over here. So I'll just take these set of values. So A equal to B. So what am I checking over here is the value stored in A same as the value stored in B? Okay, so if it is true, I'm supposed to be getting 1. If it is false, I'm supposed to be getting a 0. Okay, so let's see what has happened over here. Okay, now let's just put this in parenthesis. It's not accepting the things. Yeah. So A is not equal to B over here. So I've got a 0, which means false. Okay, now let's just try to put the same value. So A is also 5 and B is also 5. Right. So here, let's see what the value is. Yeah, I've got 1, which means it is true. Right. So that is the equal to relational operator. So please remember there are two equal to's if you have to check if the values are similar. Okay. Now let's say not equal to. Okay, A is also 5, B is also 5. Okay, so if I say A not equal to B, which is false, right? So it is supposed to be returning me a value as 0. Okay, A is equal to B over here, so it is returning me a value false, that is 0. Now let's say A is equal to 10, B is equal to 5. Now if I say A is not equal to B, it is true, right? So true in binary means 1, so it is returning me a value as 1 over here, right? So this is my not equal to relational operator, and let's take greater than. Now this is quite understandable, right? So 10 is greater than 5, true. Okay, so that will be returning me a value 1. Okay, then 10 is less than 5. What is it? It is false, right? So it will be returning me a value 0. Okay, then less than or equal to, it is also supposed to return me a value false, that is 0. Okay, then greater than or equal to, let's just run this. It is supposed to return me a value true, that is in binary 1. Okay, so these were the relational operators, guys, and that's it. You don't have any other relational operators. These are the basic ones and the very important ones. Okay, so let's go for the other part, the other type of operator what we have in our bucket, that is a logical operator. Okay, very very important operator, guys. We have and operator, or operator, logical or operator, and negation over there. That exclamatory symbol is a negation, right? So how exactly does this work? Let me just tell you. So I believe you know what a logical AND is, right? So if you take two inputs, logical AND will return a true value only when both the values are true, right? So let's say I'll be taking two values. The first value is A equal to B. Okay, this is true. Okay, so I'll apply a logical AND operation over here. A equal to B and okay, B equal to A, which means that Okay, I'll just change the value over here to 5. Okay, A is also 5, B is also 5, which means that this is also true and this is also true. Now let me just try to run this particular code and check what exactly happens. Yeah, it is returning me a value true, which means that AND operator, logical AND operator will return me a true value only when both the inputs are true. Right, so this is also true. A is equal to b, that is true, and b is equal to a, that is true. And logical or operator, okay, that will return me a value true only, that'll return me a value true if any of the inputs are correct. Okay, now let's just say I've changed this particular a value to 10, and I've changed this relation operator to a greater than b. Now here only a greater than b is true and b equal to a is false, right? So this is a true, this is false. So true and false, sorry, true or false. Let's check what exactly give me the value. It is giving me the value as a true, right? So that is exactly how it works, guys. When it comes to your what is that? A logical or operation. Now, what is negation? Okay, this exclamatory symbol is nothing but your negation. Now, let's say I want the opposite, uh, value, whatever I have got. So a greater than b is actually correct. So it is supposed to be true, and it is supposed to return me a 1 as the output. But if I put a negation symbol over there, it will return me the opposite thing. Right, so 10 is greater than 5, that is true. But if I put a negation symbol over here, it will return me the opposite one, that is false, or simply in binary terms, it is a 0. Right, so this is your what is that? Logical operators. And next up, you've got your very interesting operators that are nothing but bitwise operators. Okay, so all these operations, be it your single ampersand, a single dash, that is bitwise OR, and that cap symbol, what you can see, it is XOR. Okay, bitwise XOR. And then the tidal symbol, okay, the wave like symbol, what you can see, it is called as the tidal symbol or tidal symbol. It is the complement, one's complement. Okay, and then the two less than symbols, what you can see, that is left shift and then right shift. Okay, all these are slightly complex bitwise operators. So for time being, just understand that whenever these operators are used, they are used in the terms of bits. Okay, the numbers are converted, or the anything what you are operating on, they converted to their basic bit forms, and then these operations are performed. Okay, basically in terms of binaries. Okay, so we'll not be discussing this complex things over here, guys. So whatever is important for you, whatever is required, I have told you. And apart from this, I believe I have also told you one more operator called as size of. Right, in the previous videos of mine, I have told you size of is a operator. So even though it looks like a function, so this operator basically what does it do? It returns me the size of any of the data types. Right, so even if I take a, okay, a is declared as an integer type of data. Right, so integer type of data stores 4 bytes of space. Right, so here it is giving me the value as 4. So this is one special operator what I can call. And then there is something called as ternary operation. So the ternary operation syntax basically is true value. Okay, first there will be a condition. Okay, first there will be a condition, then there will be a semicolon, then the true. Okay, and then one more called as false. So this is syntax of your ternary operation, which I will be discussing in the loops videos. Okay, so you don't have to worry about that. So that's it, guys. We have come to the end of operations. But did you see any flaw in this particular thing? Okay, so if you have not noticed, when I used a divided by b, okay, so a divided by b means it is supposed to divide 10 by 5, and it is supposed to be returning me a value of 2, which is absolutely correct. Okay, now let's say I do the opposite. Okay, I divide b by a. Okay, now what exactly happens? Now the output is going to be a 0. Okay. Okay, so now we're supposed to check which number is greater, and that is supposed to be divided by the smaller number, or else we will not be getting the appropriate output. Right, so how do we check which number is greater? Okay, we'll have to use certain conditional statements. Right, so this I'll be discussing in my next video, guys. So how to use the conditional statements, how to check which number is greater or smaller, or what the conditions are. So till then, happy learning. Hope you like the video.
Do not forget to subscribe and do click on the bell icon so that you get notified when the further videos are released. And also check out our Instagram page and WhatsApp broadcast services. The links are in the description below.